This video has been created for the revision for paper 2 and 3 for higher AQA. These are the highest predicted topics to come up on those papers based on what hasn't come up on paper 1. These are the topics that we're going to revise, so obviously they are suitable for future papers where you need to revise these topics too. So off we go. Sequences, we're going to go through the different types of sequences, making sure that we're covering your arithmetic, Fibonacci, quadratic, geometric, etc. We're going to look at formal direct inverse proportion. So that's the grade 7 one as opposed to the grade 5 that you'd see on foundation. We're looking at gradients and intercepts when given 2 points, y equals mx plus c, speed, distance, time, and how we can use our calculator for those paper 2 and 3, how we can use our calculator for those speed, distance, time calculations, SOHCAHTOA and right angle triangles, volume of 3D shapes, percentage of an amount and increase, etc. Okay, let's go. So a linear sequence is where it's going up by the same amount each time. You do need to know that that is called an arithmetic sequence too, and it is where we are adding and subtracting a constant amount. A quadratic sequence we know is when the second difference is the same. We're looking for the second difference of that quadratic to be the same. A geometric is when we're multiplying and dividing by the same amount each time. Now, a Fibonacci is where we add together the previous 2 terms. Now, what does that look like? 2 terms, what does that look like? So if we started with, for example, 1 1, then we'd add together 1 and 1 to make 2, we'd add together 2 and 1 to make 3, etc. Now higher, beware, they could give you this as an algebraic sequence. So for example, you could start with x, it would then be 2x, it would then be 4x, 3x, apologies, etc. You know, and it's going to keep adding up each time, so make sure you're aware of the different types you could have. A triangular sequence, so that starts with the number 1, it then goes to the number 3, it then goes to the number 6, and there's a pattern. You're adding on 2, then you're adding on 3, then you're adding on 4, and you're adding on 5, etc. Just make sure you can recognise those bottom 2. So we're going to delve a little bit more into the linear and the quadratic, making sure that you can calculate the nth term of those. So here's your classic linear sequence. This one, as you can see, is going up by 3 each time. If it's going up by 3, whatever number it's going up or down by, that goes in front of your n. So plus 3n. We don't need the plus because it's a positive, but that 3 has come from that number there. 2 ways of doing the next part. Either we say, well, what would the term be before? And the term before would be a 3 as well. If we're adding 3 in that direction, we'd be subtracting 3 in that direction. So it's plus 3 because it's a positive, and that 3 has come from there. The other way of doing it, people say, is what's the difference? How do I get from 3 up to 6? I'd be adding on 3. Note, if you are going down for this sequence, if you've got a sequence, I don't know, that's going 10, 8, 6, etc., then it's a negative 2 in front of your n. So it would be minus 2n plus 12 in this case, minus 2n plus 12 for that one. Right, okay, a geometric is where you're multiplying by the same amount each time. So the first thing we need to do is work out how we're getting from 6 to 24, from 24 to 96, etc. Now, one way of doing that, if it's a tricky one, is doing 24 divided by 6, 96 divided by 24, etc. And it gives us 4, okay? We're multiplying by 4 each time as we're moving up. Oops, multiplied by 4. So if it's multiplied by the same number, that becomes a geometric. A few things you need to know for geometric, that the first term is called A. A is the first term, that's 6. R is the common ratio, which would be 4, and your nth term is AR to the n minus 1. Okay, that is your nth term. So if I wanted the 10th term, it would be 6 times 4 to the power 10, take away 1 is 9. Okay, that would be my 9th term. Would be 6 is A multiplied by the common ratio, which is 4 to the n minus 1. which was going to be 8. Okay, because 9 take away 1 is 8. You'd put that into your calculator and you'd get your answer. Quadratic sequence then. So this is where the second difference is the same. So first of all, you could start by working out your first difference for all of them, okay? So there's my first difference, 13, 19, 25, 31. And we then work out the second difference. So how do I get from 13 to 19? I'm adding on 6. 19 to 25, I'm adding on 6. And 25 to 31, I'm adding on 6. Right, so if the second difference is the same, then it becomes a quadratic. Step 1 is to find the number that is in front of the n squared. And we do that by taking our second difference. We divided it by 2, which is 3. And that is the number that goes in front of the n squared. So it's 3n squared. Right, second step is to subtract the 3n squared sequence from our sequence. Now, just because I'm running out of space, I'm going to delete this. And we're doing the 3n squared sequence, which we're going to subtract from our sequence. So 1 times 1 is 1 times 3 is 3. 2 times 2 is 4. 4 times 3 is 12. 3 times 3 is 9. 9 times 3 is 27. 4 times 4 is 16. 16 times 3. Sorry, what am I on? Yeah, 4 times 4 is 16. 16 times 3 is 48. Okay, and you can keep going, but there's no need. We now need to subtract the 3n squared sequence from our sequence. 6 take away 3, 19 take away 12, 38 take away 27. Okay, that should be enough now because we need to do the nth term of this sequence. So it's going up 3 to 7, 4, 7 to 11 is adding 4. You should now find you've got that linear sequence again. So we do the nth term of the linear and we're done. So this one is 4n and my term before, or how do I get from 4 to 3, is going to be minus 1. Okay, so you add those together, we have the sequence 3n squared plus 4n minus 1. 3n squared plus 4n minus 1. There's your nth term. Okay, moving on then. So we're now on to proportion. I am going to take you through the formal equations, but let's just cover the direct and inverse to kind of start with the graphs and what they look like. So direct proportion is where it's going up by a constant amount each time. Now we don't know what the constant of proportionality is. We don't know the steepness of this curve, but it could be anything that looks like that. Okay, inverse proportion, however, as one is increasing, the other is decreasing. If one's being multiplied by 2, the other side is being divided by 2, creating a graph that looks more like this. Okay, sorry for the wobbliness there, but it's something like that. Now, for direct proportion, we say that y is directly proportional to x, and therefore y is equal to a constant of x. And for inverse proportion, we say y is proportional to 1 over x, which is therefore y equals k over x, a constant over x. So here's a question: y is inversely proportional to the square root of x. So square root of x inverse. When y is 12, x is 81, and we're going to use that to formulate our constant to find the value of x when y is 81. So the first mark, let's get this part down. Y is inversely proportional to the square root of x. Y is directly proportional to 1 over square root of x. And then we can change to an equals. Y equals the constant over the square root of x. Now, we need to figure out what our constant is, and we do that by inputting the values of y being 12. So we're going to sub that one in there. And also the fact that x is 81. We're going to sub that one in there, and we're going to figure out k from that. So 12 equals the constant divided by the square root of 81. So 12 equals k over 9. Therefore, k is going to be 12 multiplied by 9. 12 times 9, which is 108. So from that, we've now got our formula. And our formula is, let's just subsection that part off a bit. Our formula is y equals 108 over the square root of x. So I've literally just put in the 108 in place of our constant, okay, up here. We can now use this, find find the value of x when y is 81. Okay, so 81 equals 108 over the square root of x. And we can now figure out the value of x. Now I'm just going to clear this, a bit more space to work with. And write it up here, 81 equals 108 over the square root of x. Okay, so I'm going to start this by multiplying 81 by root x. So 81 root x is 108. I'm then going to divide through by the 81. So root of x is 108 divided by 81. And I'm then going to square my x. So x is 108 over 81 squared. Put it into your calculator and get your answer. Okay. Right, next part then is y equals mx plus c. So you could be asked to generate an equation of a straight line that goes through 2 points. So here we go. I've got my 2 coordinates and we need to do the equation from that. So the first thing you need to know is that this is the formula for any straight line, y equals mx plus c. And you'd need to write that down. And we know that m is the gradient, which is the steepness of the curve, found by doing the change in y divided by the change in x. And c is our y-intercept. Okay, so let's put that into practice. So you can draw a line between them if you want to. There we go. Okay, and the first thing is to pick 2 coordinates on the line where we can generate the gradient from. Now, I'm just going to use the 2 points I've been given because I know they're exact points. So let's have a look at that first. We need to do change in y divided by change in x. So how much has it changed in the y divided by how much it's changed in the x? Change in y divided by change in x. So in y then, it's gone from the coordinate of 1 up to the coordinate of 4. So it's got a change of 3. And in the x, it's gone from negative 2 to 2, which is a change of 4. So my gradient is 3/4. Okay, or 3 over 4. Now, remember, we can do that by doing the second y coordinate, subtract the first y coordinate, over the second x coordinate, subtract the first x coordinate, okay? But 3/4 for that one. So we can now sub that into our formula. Now, it looks like it pretty nicely goes through 2.5. But let's just look at an example where it might not. Y equals mx plus c. Y equals 3/4 of x plus c. Now to find your c value, what you need to do is substitute in y, any coordinate. I'm going to choose the positives one. So y is 4 and x is going to be 2. We can substitute that in to get a nice value, to get a nice c value. So y was 1. 1 equals, y was 4, sorry. I've covered over it myself. 4 equals 3/4 of 2 plus c. So from that we have 4 equals, well, 3/4 of 2 is 1.5, isn't it? 1.5 plus c. And then we're going to subtract that 1.5 from both sides. So 4 subtract 1.5 is 2.5. Please work in fractions if it's easier for you. C is 2.5. So final equation is y equals 3/4 of x plus 2.5. I'm going to write it as 5 over 2. Okay. Right, there we go then. So knowing that m is the gradient, c is the y-intercept, and that's how we get our line. If you're asked for a perpendicular to a line, let's just quickly cover the perpendicular to a line as well in case you're asked for that. Let's just keep up our final equation. So let's just cover perpendicular. So perpendicular is the negative reciprocal. So perpendicular line would be, gradient would be -4/3. Okay, we take the negative reciprocal of it. If you then wanted an equation of the perpendicular that, for example, went through the coordinate 2, 4, we would start with y equals -4/3 x plus c. You would substitute in your values 2 and 4. So whatever they're telling you that you want to, whatever coordinate they're telling you they want it to kind of go through, substitute in those values. And from that then you can find your c value and you've done it, okay? So y is 4 equals minus 4/3 of 2 plus c, put it into your calculator, get your c value and put your c value back into there. Okay. Right. Speed, distance, time. Okay, key here. You need to use the time button on your calculator. There's so many questions where you are maybe given something in hours and minutes, but you want it in kilometers per hour, for example. So you need to get used to converting between those different forms. Know your formulas, right? Personally, well, I know some teachers are against it, but I use the formula triangles. Other students have just learnt bits, but I definitely still use the speed, distance, time triangle. When they're next to each other, we're multiplying, and when they're on top of each other, we're dividing. So from that, we can get three formulas. Speed equals distance divided by time. Distance equals speed times by time. And your speed and your time, apologies, is equal to your distance divided by speed. So I've got my three formula there that I kind of need. Okay, right, what do we do now then? So we need to make sure that when we get a question, our units are in the correct form, and I'm going to show you that button on the calculator and how we do that. So here we go. A car travels 250 kilometres in 3 hours 26 minutes. Right, that's our problem, look. We're given a time in 3 hours and 26 minutes. It wants the answer in kilometres per hour. So speed equals distance divided by time. That part should be okay. We've got our distance as 250. What we haven't got is our time in hours, and it has to be, if it wants it in kilometres per hour, we have to have the units as kilometres for distance and in hours for time. Now, 3 hours 26 minutes. What we're going to do is we're going to use this time button here. It's located here on the Aura. If you've got a Casio, I think it's a dot with 3 dashes, but it's very similar. Every time I say a unit of time, so every time I say hours or minutes or seconds, I'm going to press that button. So 3 hours 26 minutes is put in like this. 3 hours 26 minutes. Okay, press equals and it shows it down here. This just checks that you've got it correct, as you wanted it. 3 hours 26 minutes and no seconds. That's exactly what we want. Now, by pressing your fractional to decimal button or your SD button on the Casio, you will see that it first converts it into a fraction and then it converts it into a decimal for you, 3.43 recurring. Now I can use that calculation, 3.43 recurring. I'm just going to put 4.3 and then I'm going to type it like that into my calculator. So 250 divided by, I'm going to use the answer button, that is my stored answer in the calculator. Okay, we want it back into a number, so there we go, 72.82 to 2 decimal places. Oh, we're speeding here. 72.82 kilometres per hour. You can tell I made the question up. There we go. We'd never normally do speeding in a GCSE question, I'm sure. 72.82 kilometres per hour. So get used to using that time button. Once again, every time you say a unit of time, we're pressing the button. So it's really common for 5 minutes, someone to put 0.5, for example. But if we're talking 5 hours and 5 minutes, 5 hours and 5 minutes, that would be 5.08 to 2 decimal places, okay, 5.08. But please use that answer button, the stored answer, to show you to do the full working out. Okay, let's keep going. So SOHCAHTOA is one of the next predictions to come up. I think that other trigonometry will also come up, but let's just go over SOHCAHTOA for this video and I'll upload some more on the others. So SOHCAHTOA, please remember, has to be a right angled triangle. If you're doing higher, you've got various ways of figuring out angles and sides now, but SOHCAHTOA is purely for right angle triangles. The other ones work in all triangles. SOHCAHTOA is right angle only. So you are given an angle or you're asked to find an angle and we label it up correspondingly. So we've got the opposite, which is opposite the angle given, the hypotenuse, and we've got the adjacent. So say in this question, we're given that that's 13, that's 21 degrees, and we're being asked to find the adjacent. How do we choose our ratio? Write out SOHCAHTOA. Make sure you get the letters correct, please. So you're given the opposite. And we are trying to find the adjacent, so we want the one that involves the opposite and the adjacent, and that's going to be your tan ratio, TOA. Okay, so we're trying to find the adjacent. For that, we're going to do the opposite divided by the tan of the angle. Adjacent equals the opposite divided by the tan of the angle. Put it into your calculator and get your answer. Please make sure your calculator is in degrees. If it's not in degrees, we're not going to be getting the right answer. So 13 divided by tan 21. There we go. 33.87. 33.87 to 2 decimal places. There we go. Right, okay, so we're going to try this exam question. Now, this is a two-step question where we're being asked to find this angle here, this angle X. Now, the way to think about these types of questions is to separate it up into two triangles. We're trying to find the angle in the triangle 2, but we haven't got enough information. We need two sides for the one angle. We've only got one side, one angle. So what we need to do is first find another side. And we're going to do that by finding this side here, using triangle 1 in order to do so. Now the first one is a Pythagoras. We've got two sides. We need to find the third. And it's a shorter side we're finding. So we're doing the square root of 18 squared, subtract 13 squared. Okay. So start by finding that one. Square root of, let's clear that, square root of 18 squared, subtract the 13 squared, which gives me root 155. I'm going to keep it as root 155 to keep it exact. And then we can use trigonometry then for the second one. So we've got the opposite, we've got the hypotenuse. So it's going to be the sine ratio. We're trying to find the angle, so we're doing the opposite divided by the hypotenuse. The sine of x is equal to the opposite, which is root 155, divided by the hypotenuse of 19. Now remember to use your inverse sine button, root 155, divided by 19. Remember to use the inverse sine button in order to kind of help that. So I've got that stored into my calculator. Shift inverse sine of root 155 divided by 19. 40.9 to 1 decimal place. 40.9 degrees to 1 decimal place. Okay, so those two steps, just be careful. Finally then, it's percentages as well, and volume of a 3D shape. Can we just remember, please, the formula is in there, right? The formula is in your sheet, but it's the area of the cross-section at the front of the shape multiplied by the length of the shape. So if it's a cylinder, it's the area of a circle times by the length. If they give you the area, if they're telling you that's 5 centimeters squared and the length is 10, just do 5 times by 10, but it's all to do with the area times by the length. Make sure you remember key formula that aren't on your sheet. So trapezium is, circle is, triangle isn't. So triangle is base times height divided by 2. Yeah, just make sure you're okay with using those. But area of the front of the shape multiplied by the length. Percentages. Right, when now we've got a calculator, I'm just talking paper 2-3 here. Please use your decimal multiplier button. So percentage of an amount, just do the decimal multiplied by the amount. So if we want 12% of a number, 12% of 826, we're doing 0.12 multiplied by 826. So the decimal equivalent multiplied by the amount. Increasing and decreasing. If we're increasing, we're adding it on to 1. And if we're decreasing, we're subtracting it from 1. So a 12% increase, your decimal multiplier would be 1.12. I'm adding 0.12 onto the 1, so it'd be 1.12. Decreasing, so if it's a 12% decrease, then I'm doing 1 take away 12%, okay? Giving me 0.88. Okay, so just make sure then that we're okay. I should have written 1 minus our percentage rather than subtract 1 away from it. We're subtracting it from 1. So then you just multiply it by the amount. So if I wanted 12% increase of 826, I'd do 1.12 times 826. A decrease of 12%, 0.88 times 826. And your percentage change formula is the difference between the two numbers, divide it by the original and multiply it by 100. Okay. Right, I hope that helps. I'll be uploading some more videos, so like, subscribe, and you'll see more.